Maturity dictionary meaning is fully developed. In concrete production, it means that our concrete has developed its strength for use or other applications. We may measure its maturity to solve or to open to traffic. Maturity concept uses the relation between concrete strength and time temperature. The maturity concept use, assumes that for a mixture with same maturity, the concrete strength development will be the same. The monitored concrete temperature history and age is used to find maturity index and to predict concrete strength according to the pre-calibrated relation. In this presentation, we will give some background information on concrete strength development in the field and the relation between concrete strength and maturity, and how concrete maturity testing can be used to monitor the real-time strength of concrete. Some field applications, examples, and tips and benefits of using concrete maturity will be given. Monitoring concrete strength has great benefits, but it is also a safety issue. There are some historical examples where forms are removed earlier and deadly accidents have occurred. So monitoring concrete strength is important, but how will we determine it? If we do not monitor concrete strength, we will have to wait too long to strip off forms or open our pavement to traffic. These will cause the project to be unnecessarily more expensive. To sum up, the benefits of monitoring concrete strength are formwork stripping and cycling, determining post-tensioning time on concrete, determine the effectiveness of the curing method. Especially in mass concrete, heat of concrete might go higher, so temperature needs to be measured. For pavements, early opening the pavement to traffic and even determining sowing time is also important. If concrete strength is not monitored accurately, it might cause increase in expenses, safety issues, or structural collapses. There is a good relation between concrete curing temperature and its strength gain. As curing temperature increases, concrete strength in early ages increases. But this relation is specific for the mix design used. As cement type, content, water-cement ratio, admixture, ingredients change, this relation also changes. Curing temperature of the structure does not remain the same, but there is a good relation between the temperature exposed and duration with strength for a specific mix design. To predict the strength of a concrete by monitoring temperature, an Astm specification is also developed, which is C1074. This method is called maturity testing. In this method, strength maturity relationship is established for the concrete mixture in the laboratory. The temperature development is recorded for the concrete, whose strength will be estimated. Relation between maturity index and concrete strength for each concrete mixture should be established individually. The basics of the concept is that if the area under the temperature time diagrams are equal, the strength for that area is also equal. Maturity testing has also some limitations. First of all, strength in place always differs because of inadequate compaction and water curing in the field. But this limitation is also valid for field cured specimens, which will be reviewed in more detail in the next slide. High early temperatures can also be misleading in maturity testing. Changes in the mix designs affect the relationship established and might require new tests to be done. Datum temperature is chosen during establishing the relationship. This is the temperature under which no hydration reaction is assumed to go on. According to the chosen value, the results changes. Field-cured specimens are assumed that they have the same strength as concrete element, but it is not the case. It is very unlikely that they both have the same curing temperatures. Concrete specimens' area to volume ratio is much higher than the concrete element, so they are more sensitive to temperature changes. They are also more sensitive to curing conditions. Concrete specimens are most of the time unprotected in a corner of the construction, so it is not representing the concrete in the structure. The results from the laboratory, in most cases, are not coming in a timely manner. This also causes delays in the projects. Most of the time, number of samples dedicated for field cure is only one. And what will be done if the sample fails? Also, field cured specimen only resembles the strength for the curing pattern it had experienced. So we will not be able to monitor the strength variation in the structure. There are also some other methods to monitor the strength gain of concrete. Some of these methods are even partially destructive, but among these maturity is the one which can be applied easily and which is reliable. Astm C1074 gives two methods to build a relationship between time temperature and strength gain. These are Saul temperature time factor and Arrhenius equivalent age methods. In this presentation, we will only give examples for Saul relationship. In Saul relationship, temperature time diagram is obtained, then a datum temperature is assumed. The area above datum temperature is calculated, and this area gives the maturity index. The concrete with the same index is assumed to have the same strength level. Datum temperature is given most of the time by specifications, but it can also be calculated according to ASTM C1074 Annex A. To establish a relationship according to ASTM C1074, minimum 15 samples should be taken. Their temperatures are monitored and recorded every half an hour for the first 48 hours and after 48 hours every 1 hour. The compressive strength of 3 specimens is measured every 1, 3, 7, 14 and 28 days. Now we have age compressive strength relation and maturity index age relation. We can combine them together and obtain a linear relation between strength and logarithm of maturity index. Concrete strength, especially for early ages, is more critical, so the times for strength measurement can be changed accordingly. Since we have the relationship, now we can monitor the strength development in the field. We record the temperature with time, we calculate a maturity index, and we can make an estimation of strength for each time interval. We do not have to break a cylinder and wait for the results. We can put the sensors to several locations and we can obtain the estimated strength for each location individually. It is very important to obtain the calibration curve again if there is a change in the ingredients of concrete. Cement, supplementary cementitious materials, and admixture changes or dosage changes will affect the results. There are also some critical decisions to be taken before starting a testing in the field. Which element is more critical? In a structure, the structural engineer will help you to decide where to put the sensors because the section's dimensions or the load it holds in fresh state might affect these decisions. How deep the sensors should be installed? In a calibration, they are embedded in the middle of the specimen. Keeping them in the middle of the member might be a good idea, but structural engineer's decision for critical areas, depths, should also be taken. When should we start recording the temperature? Recording should start as soon as concrete is cured. How many should we install? In all critical locations with a spare sensor for each, because sensors might get damaged during curing. MINDAT in 2018 specification has a devoted section for maturity strength relationship in 2461. In this section, the concrete types of concrete which this method can be used are given as concrete pavement repairs, concrete structures, or sidewalks, driveway entrances, curb and gutter. And in this relationship, it says, until an acceptable strength-maturity relationship is established, verify strength using concrete beams or cylinders. In the same section, the procedure for concrete maturity is also given. Estimate the in-place concrete strength using the maturity method as described in Astm C1074, except as noted in the specification as follows. Fabricate 15 cylinders plus 2 additional cylinders to embed temperature sensors, or 15 beams. The Nurse-Saul method of computing maturity, a datum temperature of 14 Fahrenheit, and maintain the specimens as temperatures greater than 50 Fahrenheit during the maturity curve development. Test three strength specimens at 5 different ages specified in Table 2461-20 for the type of concrete work. In 2461-20, according to the type of concrete, the testing ages are given. For concrete pavement, since it is opening to traffic, it is determined by the contractor. Normal strength concrete is 1, 2, 3, 7, 28 days. High early strength concrete, 12 hours, 1, 2, 7, 28 days. Ultra high early strength concrete, 3, 4, 8, 1, 3, 4, 8 hours, 1 and 14 days. Let's calculate an maturity example. This is the laboratory curing conditions and strengths we obtained. Assume that the laboratory temperature was constant, 67 Fahrenheit, and when we calculate according to MINDAT datum temperature, we obtain the maturity index as follows. We calculate the area, subtracting the datum temperature, and we obtain for 1 day 1272, for 3 days 3816, for 7 days 8904, 14 days 17808, for 28 days it is 35616. Now we can plot our maturity index and concrete compressive strength diagram. And this is not logarithmic scale. If it's the normal scale, we obtain a diagram like this one. When we plot the maturity index in log scale and strength in normal scale, we obtain a linear diagram. And according to the values given before, we plot the diagram as given. Now we can go to the field and obtain our maturity index from the field and estimate our strength. For example, we have the maturity index 1450 hours Fahrenheit. From the calibration diagram, we can read for 1450 hours Fahrenheit, strength is about 2200 psi. If our aim is 3000 psi to remove the forms or open to traffic, we need 3816 hours Fahrenheit. If we subtract the hours Fahrenheit we have gained, and now we have 2366 hours Fahrenheit. And if the average curing temperature for the following days is 50 Fahrenheit and the datum is 14, now we have to wait like 65 hours to remove the forms or to open to traffic. But we should check after 5 hours and our records for maturity index if the predicted average temperature might not be right and might not be reached.